Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudewa Sos Ugobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we have question 4, and then we are given f of x is equals to 2 over x, which is obviously a hyperbola function, and g of x is equals to x minus 1, which is a straight line function or a linear function. So we know that they always like to combine these two. Now 4.1 says determine the coordinates of the point where the two graphs intersect, right? So what are we supposed to do? In order to calculate the point or the points where the two graphs intersect, we know that we have to equate the two graphs here. So we have f of x is equals to g of x, right? Now we take the expression for f of x and then take the expression for g of x. Now to calculate our x value, we need to cross multiply here. So that's 2x times x, that's x squared, then x times negative 1, that's negative x. Now to solve this, we will say x squared minus x minus 2 is equals to 0. So let's try to factorize here. We will have x minus 2 and then x plus 1 equal to 0. And then this is x is equals to 2 or x is equals to negative 1. But then remember, we are to calculate the coordinates. So that means we want the x values and the y values, right? So how do we get the y values? We can use any of these equations here. We can use f of x, we can use g of x. It's mainly our choice. So let's say maybe we are using the straight line. Then we just go g. And then when x is equals to 2, that's supposed to be 2 minus 1. And then that's going to give us 1. So the coordinates are 2 is to 1. And then what about if g is equals to negative 1? We're going to say negative 1 minus 1. And that's going to give us negative 2. So our coordinates are negative 1 is 2. Negative 2, right? So now we have our two coordinates for the point of intersections. So that means the graph of f and g intersect at 2 is to 1 and also at negative 1 is to negative 2. Now 4.2 is saying on the same set of axes, draw the two functions, indicate the coordinates of the points of intersection of the two graphs. So note that we must indicate these coordinates of the point of intersection. So in order to draw, we know that number one, we need to have our Cartesian plane. So let's have our Cartesian plane like this. Make sure it is straight like that. Okay. And then now, looking at this, we can see that that simply means that our vertical asymptote is 0, and as well as our horizontal asymptote is 0. So that means our intercept will be the axis here. So that means drawing a smooth curve around these ones. So smooth curve. Okay. And then also here, because it won't touch the x-axis and the y-axis. I'm trying to make it as smooth as possible. It's kind of slippery, but then okay. So now we have our graph of f like that. And then now we must indicate the straight line graph. But then in order to indicate the straight line graph, we need at least 2 points, the y-intercept and the x-intercept. Now to calculate the x-intercept, we know that we make y 0. So this is x minus 1 is equals to 0. Our x is equals to 1. So we're just going to indicate it somewhere there. So that's 1 is to 0. And then to calculate the y-intercept, we just make x 0. So that's y is equals to 0 minus 1. Our y is negative 1. So let's indicate it there. So this would be 0 is to negative 1. Now, let's draw a straight line joining those 2 points for the straight line. So for the straight line, joining those 2 points like that. So there we have it. There we have it. And then let's indicate now. So this here would have to be our graph for G, and the red one here, our graph for F, the hyperbola, right? So now we have our points of intersections here at this point. Point of intersection. Remember here, this one corresponds to the point 2 is to 1 that we found. And then this one corresponds to the other point that we found, which was -1 is to -2, right? So just like that, we have clearly indicated our point of intersection, and then we've also indicated the y-intercept for the straight line graph. But then here they were only interested in the coordinates of the point of intersection for the two graphs. So I guess this is what they're gonna mark here, and then also the shape, right? Okay, so now that we've drawn this, 4.3 says use your graph to determine the values of x for which 2 over x is greater than x minus 1. So here they just didn't want to write it like this, but this is still the same thing. This is where f of x is greater than g of x, because looking at this expression here, we can see that it is the equation of f of x, or the graph of f of x. And then looking at this expression, we can see that it is the graph of g of x. So what is the interpretation of this? F of x greater than g of x. This means where is the graph of f above the graph of g? So when you are able to interpret that mathematical language into simple English, then it becomes very easy to answer that. Where is the graph of f above the graph of g? So we're going to use our method of just indicating horizontal lines first. So let's indicate the horizontal lines. So I'm just going to pick the points of intersection. So point of intersection, then I indicate a straight line like that. So also here, straight line, and then another point of intersection again, and then I just indicate a straight line like that. Okay. So now I'm looking for the points where we will see our red graph being above the blue graph. Our graph of f, red graph, being above the graph of g, blue graph, right? So, okay, let's find out. So this is what we're going to do. For that part, we can see that if we can just come to this point here, have a look at what we have here. So might not show correctly because my lines are not so straight, but then we can see that around this area here, the red graph is above the blue graph. And then what are the coordinates there? We can see our x coordinate is -1, but then it's going to the left direction. So we would indicate that solution as what? So indicating the value of that solution, we're going to now say this is when x is less than -1, right? Now let's look for the other part where we see the same thing happening, the red graph being above the blue graph. So if you can just bring your eyes over to this area here. Bring your eyes over to this area. Now you can see the same thing is happening. The red graph is above the blue graph. But then remember, for the red graph, it cannot touch this part here. It cannot touch where x is equals to 0. So when we indicate the solution to that, we need to say where x is greater than 0 or x is less than positive 2. So remember, at this point, we are saying they are equal. So that point cannot be included. Or you can write this as x element of 0 all the way to 2 using round brackets, because the 2 points here, 0 and 2, are not included. 0 is not included because f does not touch there. It's the asymptote. But 2 is not included because at that point, the two graphs are equal. But then here we are only looking for the point where the graph of f is above. It does not have to be equal. It does not have to be below. It needs to be above the graph of g. So these are the two solutions that you have when x is less than -1, which is this side here, and then when x is an element of 0 to 2, which is this region here. Okay, so I hope that makes sense. Now, 4.4 says if f of x is equals to 2 over x plus 3 minus 4, describe the transformation that takes f of x to g of x. Now, our f of x was just 2 over x, as we can see from here. Now, we want the transformation that took it from this f of x to this h of x. Now we can see here there's a plus 3, but then remember, if there's x plus something, that means the shift has happened on the left hand side. Because if you can just take x plus 3 and then equate it to 0, then x is equal to -3. So that -3 is telling you that the shift was to the left hand side. So you need to say graph of f was translated, or you can say shifted, was translated 3 units to the left. And remember here, we said this one, if it's negative, it's going down, but if it's positive, it's going up. So this one is just straightforward like that. So graph of f was translated 3 units to the left and 4 units downward, because it's negative. 4 units downwards. So this is the translation that took place there. Graph of f was translated 3 units to the left and 4 units downward. And that's it for the lesson, guys. Please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. And if you are watching this from Facebook, please like and follow the page. And also don't forget to share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.